platforms.
Yeah. Okay. Is it audible? Yeah. So this demo talk is the second part of the talk that you heard from Professor Yogesh Simman about scalable big data platforms. So I'll be giving demo of Hadoop and Giraffe and probably Apache Storm. So So if you remember yesterday's talk, so probably Professor has talked about two big data platforms, one about the batch processing system and other about the stream processing system. So basically what's the difference between a batch processing and a stream processing system is that in a batch processing system, you have entire output, entire the data as your input. And while in case of stream processing system, the input that is given is coming instantly. For example, let's say you are given a graph and you want to find out, let's say web graph, and you want to find a page rank. So in that case, the entire graph is provided as an input to your batch processing system. Whereas consider the stream processing system, like you want to find out what is the current hashtag that is trending on Twitter. So in that case, a continuous stream of tweets will be as an input to a Twitter stream, right? So first of all, I will talk about batch processing systems. The basic one, Hadoop. So if you remember, this is a simple example of word count in Hadoop. So the input is, let's say, some text file you have, and it is distributed. Okay, sorry. So Hadoop mainly consists of two parts. One is the distributed file system, and other is the programming model, that is the MapReduce. So this input that you have, there's some text file that is stored in a distributed fashion in the distributed file system, and that is given as an input to your programming model. So let's say you want to find out the word count for each of the word. So what you do is you will use this word as a key, and essentially you split the line by spaces and then use the word as a key, and in the mapper you will assign a value of 1 to each of them, so that the reducer will get the list of values that, for example, here the foo has 3 values. So a reducer will get all these 3 key value pairs and aggregate this, right? So finally you will get the output. Right? So basically I want to focus on how this cluster actually maps down to a distributed system, how the Hadoop works actually in the distributed system, right? So let's say you have a cluster of 3 nodes. In the yarn cluster, you have one head node which is dedicated as a node for managing the resources in the cluster. So what do you mean by resource? Like let's say I have given a machine. So what resources I have? A CPU and a memory, right? So the other nodes called as the slave nodes, there we have CPU and memory that is managed by this resource manager. So what does it actually do? Whenever a request comes for a job, it will find out the appropriate nodes where to schedule that job, right? And the second thing is the distributed file system. So let's say I have a huge file of say 10 terabytes, and I stored it on a distributed file system. So what HDFS will do, it will break down that file into different chunks, and those chunks will be distributed among the slave nodes. So how you might have heard this, like Hadoop moves the compute to the data rather than moving the data to the compute. So what does this actually mean is, so let's say my file that I want to process is present only in certain nodes of the certain set of slave nodes. So the resource manager will take that into account and map that process to a particular set of slave nodes. So let me give you a demo of this one. So I have a cluster of 4 nodes, and you can see. So on each of these are different nodes by the 4 slave nodes. So on each of this one, you can see a data node process is running and a node manager process is running. So the data node corresponds to the distributed file system. So it manages like different blocks stored in the of the data, right? And the node manager takes care of the resources. What are the current available resources? And let's say this is my head node where from I will submit the job. Okay, so for running the word count example, I have put one file in the sorry for that. So what I have done is I have kept this large text file in the HDFS. So what the HDFS will do, it will break down that file into different chunks, and those chunks will be distributed among those 4 flavor nodes that we saw. So when I want to run a word count example, for example, let's say, so what I have to give as an argument to Hadoop is the jar which has a jar file which contains the logic you want to process on that data, and the second is the input directory where you have kept the data essentially, and the third argument is where you want to see the output, right? So this is the head node. I am submitting the job from here. So now what happens actually in the background, when I submit this job, when the Hadoop command, what it does is it reads this jar file and it looks for this class that are specified. So what that class specifies is the logic that we have given, like to break the input by spaces and then map each word by the value 1. And this request is sent to the resource manager. It takes into account where that data file is actually stored in the cluster, and based on that, the task is scheduled on slave nodes. So, for example, you can see, so this file was pretty small actually for 3 GBs, and you can see it processed almost in less than 15 to 20 seconds. But you can appreciate its power only when the input size is quite huge enough. Let's say, for example, I recently processed the total web pages that are present on the internet. The 0.1% of that, when you process the same word count example, it just takes 20 minutes. So there you can appreciate its power. And the second example I wanted to go in, yesterday you might have came across the graph processing system called Giraffe, right? So what's the disadvantage of the Hadoop is that whenever it generates an output, it writes to the distributed file system, right? So there is a disk IO involved in that. But typically, you know that the graph algorithms are iterative in nature, right? So for example, let's say you run a BFS. So what happens, every iteration you come across a new set of frontier, right? So it will continue till the maybe the diameter of that graph, right? So those many iterations, and if you run the same algorithm on using Hadoop, so what will happen is that each iteration will involve writing to the distributed file system. So for those kind of algorithms, this one batch processing system called Apache Giraffe. So on that, what you can do is you can write a logic from the perspective of a vertex. So you can think like a vertex, and accordingly you can write a program. For example, this is a shortest path example. Let's say 0 is my source vertex, and this denote the weight of the edge. Okay. So how this proceeds is like the source vertex initially sets its value to 0, and it sends its value, that is the distance, to its neighbors. So for example, the 0 will in first super step, it will send the value to its neighbors. saying that my distance is 0. So it might happen that a single vertex can receive multiple values, right? So out of that, whatever is the minimum value, you choose that as your distance. For example, this vertex will receive 3 messages along these 3 edges, right? So it will choose the minimum of those 3 and it will update its distance and propagates the distance value to its neighbors also, right? So I will briefly show how giraffe works. So the giraffe also works on top of Hadoop actually. So only advantage that you get in giraffe is that it doesn't write the output on every iteration to the distributed file system. So similar to how we give an input to the Hadoop job, will be giving the input to giraffe also. So what I did in earlier run is that I kept the text file in HDFS. So right now this is we need to pass a graph to the giraffe, right? So this is the format in which I pass the graph as an input. So the first one, this is a JSON format. So it denotes like this is the vertex, and the other brackets denotes what are the neighbors of it and what is the edge value. Okay, just 5 minutes. So I've kept it in HDFS and we run it. So this is the command to run giraffe actually. As you can see, it also starts with Hadoop. That means it's essentially a Hadoop job, but it's only a map only job. It doesn't write it to the disk again and again, just iterate over the same input. And another thing involved in this, like you have right now you need to partition the graph, right? When you distribute it around different nodes, you need to specify like what is the number of partitions you want to generate, and yes, you have given here the partition count. That also affects the performance of the graph algorithm. See. So the graph that I have given as an input is having 5 million nodes. So let's see how. Okay, already exists. Okay, sorry for that. So that directory already exists, that's why it's shown error. So here again the same procedure happens, that this job is submitted to the resource manager and detects where that graph is actually present, and based on that this tasks are scheduled on different nodes. So as you can see here, I specified the user partition count as 5, and it is using 7 containers. That means the 5 partitions are working on, and there is one application master that is coordinating the entire execution of this method. So it's finished in only 39 seconds, and you processed almost 5 million vertices. That's it.
Okay, let's thank Ravikant. So you can ask questions him offline. So our next speaker is Talha bin Masood. He's a PhD student in the department, and he's going to give us a demo on symmetry in scalar fields.